So as we are still considering our ungrouped information, in this case, we are going to have a continuation presenting that information on a pie chart. We had this ungrouped data or ungrouped information being presented on a bar chart where we saw our information being presented in terms of the bars separated with the characteristics that we had. So in this case, same information on a pie chart, but how is that so? What is it that we refer to as a pie chart? A pie chart is representing this information separated in terms of sectors. A sector. Remember a sector from a circle. A sector is taken, it's a piece of a circle that is taken at a certain angle, theta. At a certain angle theta of a circle, a complete angle, a complete circle that we consider 360 degrees, but out of 360 degrees, we take a certain angle out of it. That is the theta, the angle that is given from a sector. So a pie chart is taking that to say each information is presented in form of sectors to complete a circle. So there will be a sector here, okay? Maybe it is presenting another information that you're given, maybe the number of students, whatever that you have there. Another sector is also given, our sector 2 given another information. Then there's another sector 3, another sector 4. As we are presenting these sectors, sector 1, sector 2, sector 3, sector 4, they are presented at different angles that we are having of these sectors. But together, completed, all these angles, if you add them, they must add up to 360 degrees, which is giving us a complete circle. So the information, the complete circle, it represents the information that you're given. Everything that you're given is the total information. So the 360 degrees is corresponding to the total frequency. If you're talking about, remember I talked of frequency, now you understand this when you talk of the total frequency. So when you present the total frequency, it is the one that you equate to 360 degrees in terms of the angle. When you're talking of the angle, but in terms of the numbers, you write it as the numbers that you're given. I'm saying in terms of the angle in your calculation, what is it that corresponds to that total frequency? It is the angle of 360 degrees. So as we can see, you have frequencies given, like we had. How are we going to calculate the angle of each sector? Because you've got these numbers that you are given. Remember, from your frequency table, there's a number and a frequency. This number that you are given is 1, is 2, is 3, whatever that you have there. And they have their corresponding frequency, these numbers. How are we going to calculate to say this number one that we are seeing here, what is the angle corresponding to it? Because what you need is the angle of the sector corresponding to that angle of the sector corresponding to that one. So let's call this theta. So what is going to be the angle of sector corresponding to 1, corresponding to 2, corresponding to 3? How do we calculate that? So it follows that the angle of the sector can be calculated from the concept that a circle adds up to 360 degrees. So we are going to have this way, the angle of the sector. So the angle of the sector, let's call it theta. So it follows that theta is equal to the frequency at that point over the total frequency, because I said total frequency is equated to 360. So you use the frequency, okay, let me just write in short, frequency over total frequency times 360 degrees. So this F representing our frequency. That is our frequency. And this we are talking of the total frequency. The total frequency. The total of it. So frequency at that point 1 here, what is its frequency? The frequency is 3. The total, you have to add this frequency. In this case, like this example, you're going to add 3 plus 5 as this 7. So meaning to say we've got a total of what? Of 15. So it will be 3 out of 15 times 360 degrees. you calculate each and every angle corresponding here, each and every angle corresponding. And these angles that you have calculated, they must sum up to 360 degrees. They must add up to 360 degrees. If they do not correspond to 360, it means your calculations, they are wrong. Because they were calculating out of 360. So they must add up back to that 360 degrees. So the question is, now, if I have this frequency, this and that, how do I present this pie chart? What are the features of a pie chart before we look into the example? Okay, let's just have the features of a pie chart, just like what we had on a bar graph. What is it that you are supposed to consider, to see, to say, okay, once I see this is a pie chart. This is exactly a pie chart, what is supposed to be having. One, the pie chart that we are seeing is taken from a circle. And the radius that you're going to have of this circle is not important. It is insignificant, that radius, to say, where are you starting from? So what is it that you're going to have? Each sector is labeled using the information it is representing. So each sector that you're going to have, remember I talked of its angle there. So each sector is labeled using the information, which is the data it represents. Using the data it is representing. So meaning to say, if I am given a certain information, maybe it's number of this, I'm given maybe the drink type, I have to present what is that presented there. Is it the mode of transport that I'm using? The bus? Is it by bicycle? By what? I have to write that. Is it by bus? Is it by bicycle? Yes, you can indicate your angles, but it's not important to have those angles presented. It's not important. So the radius, like I said, as you take your radius, it is not important. So let me also indicate that the radius is not like how, where are you going to have it? Like the starting point, okay, of your radius. So the radius of the circle, is insignificant. So this one, the starting point is not like we start from there. You just start from any point, but you're supposed to maintain the direction as you're going to draw the pie chart. That part I'm going to explain as we are presenting. And as I said, the theta there, we are going to have our theta. Remember, you have to present this in the form of sectors. The theta already it's part of your features to calculate the theta, which is the angle of the sector frequency over the total frequency times what? 360 degrees. Let us just say we've got an information. We want to present this information on a pie chart. So we are going to need this in our presentation. So let us just keep them aside. All right, let's say we are given a certain information to represent on a pie chart. You are given the transport means and the frequency. Okay, you are given the transport means and the corresponding frequency. The corresponding frequency. This is what you are given. Okay, let's say we are given by bus. Okay, it's a mode of transport. Okay, by walking, which is also to be considered by car. Okay, which is to be considered, and also by the bicycle, which is also to be considered. This is the information that you are given, and this is given as frequencies. Now, the frequency there is 10, the frequency is 20, the frequency is 5, the frequency is 15, like this. The question is asking to present this on a pie chart. On a pie chart. How are you going to present this on a pie chart? So like I said, the pie chart you're supposed to be having in terms of sectors. And as we saw that each sector, it needs to be calculated the corresponding angle of that sector, angle that corresponds. Bypass this. So you can just have your angle of sector aside, okay? So you can make another column, all right? So we need here a pie chart, remember? So you can even add, guys, this is an adjustment that you can do on your graph. Make an adjustment from there to indicate what is important on this one, which is what? The angle of the sector. We're not having this, but we're going to have it now as part of our solution. You are going to need the angle of the sector. The angle of the sector, the angle at the center, the angle that is at the center of each bypass. How do you calculate that? We said that theta is the frequency over the total frequency times 360 degrees. Meaning to say, we are going to have bypass, the frequency is what? So the frequency is 10 over what? So you can even write this as theta. So theta is equal to the frequency, which is 10 over. You need the total frequency to add all this. So if you're going to add 30 plus 5, 35 plus 15, which is 50. So the total frequency there is 50. So this is 10 over 50 times 360 degrees. You have the angle corresponding 72 degrees. You move on to another one. What is the frequency there? The frequency is 20. So theta is going to be 20 over what? 50, the total frequency times 360 degrees. Like that, you calculate each and every angle that you're given. The next one, theta, 5 over what? 50 times 360 degrees. You get your angle, 36 degrees, and so on. You move on. 15, the theta there, 15 over the total 50 times 360 degrees. What are we going to have? 108 degrees. So you have to calculate each and every angle from this formula. And now to present, this is it. You are not going to take this information as it is then, because you know it's a pie chart. You just draw a circle like this. You take your ruler, you just draw, and you just present. Then now we just write this is bypass. No. You are supposed to measure every angle that you are given. That's why you are seeing these instruments that are here for measuring of these angles. Okay, so the first thing, you need a circle. So we're going to need a circle. All right, so let's draw our circle. So in this case, because we need a certain point to refer to as our starting point, as we are to have this circle, which we say that radius is not important. You can just draw it of your choice. Like the radius of that circle that you're going to draw, guys. It's your choice. So let's say this is my radius, this one, okay? I'm just going to draw a line to present my radius. Let's say this is my radius. It's not important, this one. Let's say this is my radius, this one. So the radius means that I'm going to take that, okay, the needle point here at the center. So I choose, let's say I choose this to be my center. So you're supposed to place the needle point, this one, on the center. Place it on the center. The needle point on the center. With the distance taken, which is the distance of the compass, this one, this is your radius. Remember, a circle can be drawn from your construction. If you are given the radius of a circle like this, a circle can be drawn. From this radius, we just have to draw a circle at the center like that. So this is what we have. So whether your circle is as big or small, that part does not even matter at all. Draw the circle that you are comfortable with. All right, so for now, this is useless. Its job is done. Just to draw this circle, you're done. That is where it plays a role, drawing of this circle, which we are going now to separate each and every angle, because we do understand that angles at a point, they add up to 360 degrees. So out of the 360 degrees, we are going to separate these angles from this radius that I decided to use. Maybe if your radius was here, you started here, your radius, it's your own. Maybe you started this side, it's your own. So as for me, I'm going to start this side. But what is important now is as you present, follow a certain direction. As you measure your angles, follow a certain direction. It's either you're going to measure your angles going in the anti-clockwise or you're going to take them in the clockwise direction. It's up to you. All right. So as for me, guys, I'm going to take my angles in the anti-clockwise direction. I'm going to take them going this way until I'm done. All right. So let's start with the first one. The first one is given the means of transport, which is by bus. And the angle that we calculated is 72 degrees. So I'm supposed to measure 70, not to construct, but to measure 72 with our protractor. That is where it plays a role now, to measure the angle. So we're going to measure where 72 is. Remember, this here, the line, this one, the line is supposed to cover this line. This point, the center here is supposed to be corresponding to where this plus is on our protractor there. So you can cover it this way, the plus at the center, and this line covering our radius. So as we are measuring our angles, we do understand, guys, that these angles, they can be taken in anti-clockwise or clockwise. So as we take them in the anti-clockwise, they are going this way, 0, 10, 20, 30, 40, 50, 67, and so on. This is how we take in the anti-clockwise. If we take them in the clockwise, we're going to take this way, 0, 10, 20. These ones that are inside, 0, 10, 20, going this way. So you must be careful there. All right. So let me present it this way a little bit. So this is going to be like this. And this one, I'm just going to have one size so that I do not shift. I do not change the size. I'm going to present it like this. So where is 72 according to our protractor? Where is 72? So we're going to measure, that's 0, 10, 20. If we check, the 70 is somewhere there. So 72, we're going to count 1, 2, maybe 72 is somewhere there. You mark where the 72 is going to appear, somewhere there, guys, okay? So you just mark where the 72 is going to appear there. This is where our 72 is going to be. So let's say your 72 was inside the circle. That part does not matter. As you measure your angles, as you measure your angles there, as you are going to join that point, like where the 72 is, let's say it was inside of the circle like this. You now draw from the center to that point. If your point is inside the circle like this, you just draw, guys, to that point, up to the circle, you're done. Let's say your point was inside the circle, but our point is outside of the circle like that. So in the same sense, you must join looking into that point, which is outside of the circle, like the point is outside. But as you join, you do not join to the point outside. No, you join up to the circle, from the center to the circle, but focusing that point. Your ruler is on that point, but you join only to the circle. This is the part that we need. Only to the circle, but your ruler was focusing there. It was aiming that angle. That angle that we just measured, guys, it is 72 degrees. It is exactly 72 degrees. But what is it representing? It is representing, which means by bus. So you write what it is representing here by what? By bus. Don't even bother yourself to write the angle, that the angle is 72. When they are marking, they have all these instruments to measure. So do not worry to say you are saving someone's job. No, they are going to measure this. They will be having these instruments in the exam. They will be measuring each and every angle. So they must be it must be exactly 72. Yes, you are given an allowance plus or minus 0.2 or 0.3. Yeah. They give you a certain allowance to say your angle cannot be exactly 72, as we do know anything that has to do with construction, plus or minus. It's not going to be exactly 72. All right, let's move to another one. 144, representing what? 144 is representing by walking. Those are the ones that are many. 144. So let's measure that one. So again, our radius now has moved. It's no longer this one. Remember, we use this as our radius. No, our radius is now this one. We are now using this as our radius. We are moving this way in anti-clockwise. So we're going to place this line on our radius. We're going to shift until it is on that radius. So let's shift again until it covers our radius. So this is at the center, and this line is supposed to cover our radius. I'm not supposed to change. All right, it's supposed to be like this, covering the radius like this. As you can see, it's covering radius. So our radius is now here. This is now our new radius. So we measure in our anti-clockwise going this way, 144 as usual. So this is 0, 10. That's 0 here on this line covering our radius, 10, 20, 30, 40, 50. So if you check 100 here, 110, 140. So we are going to count from there, from the 140, 141, 145, just below that. That is the point. You mark that point. With the point being marked, as you can see, ours, it's outside of the circle, which is fine, this one. You join from the center to that point. But inside the circle, you are focusing with the point, but inside the circle. This is our point, remember here. Okay, and our radius here. So let's just try. Let's hope it's going to be fine here like this. But we join to the circle, but focusing, aiming the point, but you're joining inside of the circle. All right, so you're going to join inside of the circle, or radius, like this, to that point, inside the circle, inside of the circle. So this is the 144 degrees, representing what? By walking. You write what is represented there by walking. This is where we are. So this is now our new radius, this one. So now our new radius, now we are now on this radius. So we are supposed to measure the next angle, 36, on this radius, this one. So we're supposed to measure 36. So let's take our protractor, change it, shift it until the radius covers that. All right, so like this, the center and the radius here, the radius covered, that's at 0 degrees. All right, let me try to have it on top a little bit so that we can see our angle. All right, so this is where we are at the center. It must be at the center. This one covering, yeah, like that, somewhere there. It must be covering. So this is 0. No, guys, this is supposed to be covering like this. Now this is because, guys, maybe I need this, what do we call these glasses? Maybe I can see proper. So this is where we are here. So this is the 0 there. So we're going to have 10, 20, 30. We need 36. So 36, this is 35. Yeah, between 30 and 40. So 36 is just 1 point, just a small point from that. So you indicate that. So this is where our 36 was going to be here. Just like the previous case, you have to join from the center to that point, but inside the circle. Inside the circle. Okay, so let's try and see what's going to be like. This is our point here. And remember, inside the circle. So somewhere there. Okay, just a little bit, something like this. So this is what you're going to do. But you join inside of the circle. So that's inside the circle. Okay, let's have it like this. Inside, you're not, but aiming that, it must be aiming there. So this is inside up to this point. So this is the angle that we have presented from our information. What is it that is presented? The angle represented by 36 is by what? This is the car. So we are going to have the car in this region. So what does it mean? It means the remaining sector by bicycle, the 108, is the remaining sector that is also presented there already on our diagram. If we can check our diagram, there is already this part. So if we are to measure, this angle is supposed to give us 108. If we are to measure, so you can place this on any radius, you can use the radius of this one or this radius. But if you measure the angle there, it must be 108. But remember those approximation now, because guys, remember this is construction. You're measuring this. So, and also the pencil that you are using, maybe it's not that sharp enough. So, but it must be approximately to that 108. All right. So this is covering. If you check, this is 1. This is 0, 10, 20, 30, 100, 105. Yes, this is 1, 0, 5, 6, 7, 8. That's 108, exactly what we want. That's at 108. We are measuring this angle in between here, in between, like in between this part here, this part here. This is the one that we are focusing, the angle there. It is giving us 108 to show us that this is exactly what we wanted, the 108. So that is how it can be like. All right, that is how it can be like. The angle remaining. So like I said, yes, it might not be exactly 108 because of those adjustments that we're having, this and that. It might not be exactly that, but it must be approximately to that. So that is by bicycle. This is the last sector. So angles inside, they're not important. What is important is this, to write the information presented, and you can also share the color, these differently. You can also do whatever that you want. But guys, this exam, if you have that time, it's yours. And also the direction, like I said, you can take any direction. You can choose to be moving in the clockwise direction, but maintaining the same way. That as you measure the first one by bus, the radius that is there becomes your new radius. You measure from that radius. This becomes your new radius. This becomes your new radius. The last sector automatically must be equivalent to the angle that is there, the last part, approximately to that. So they can give us information on a pie chart. They can give us, because as we are not going to be having, maybe it's paper one, and as we're not going to be able to measure that, we are not this of approximation. So if they are the ones who are asking the questions, they can present in terms of the angles. This is 72 degrees. This is 144 degrees. This is 36 degrees. This is 100. They can it's them who are presenting the examiner, because they want you to use that angle for the calculations. Where I was saying now, in those questions now, 360 degrees will represent, it will represent the total frequency. It will represent the total frequency. The 360 degrees now represents, so you can use now a simple proportion. Let's just have a simple question, guys. This is what I'm trying to say. Look what is happening here. By bus, how many are they by bus? They are 10. By bus, they are 10, okay? By bus, they are what? They are 10. There are 10 people there. Then the question will ask you to calculate the number of people who are walking. If you know that by bus, it's 10 and you are given the angle, you know the angle now, that the angle there by bus is 72. The angle by walking, it's 144 degrees. Or they can give you from the whatever that you are given. You can use that as a proportion now to say, okay, 10 people which are using the bus, they are taken from an angle of 72 degrees. What about those ones by walking who have an angle of 144 degrees? How many are they? Guys, we are going to have the same number. If you calculate, this is going to be by more, 144 over 72 times 10, times 10 like this. If you calculate, guys, you're going to have the same answer. 144, if you divide this by 72, it is going to be 2. Then 2 times 10 is 20. We are supposed to have 20 people by walking. If it is not, then it means this information is wrong. So if you check, that's 20. We can calculate it from the pie chart. So they can give you a pie chart there. Is it that you are given the total frequency? If they give you the total frequency, you use 360. Maybe they'll give you the total number of people that are there. They are 300. How many were using by bicycle? Now you consider to say, okay, 360 is equal to 300. So if there is another angle of maybe 20 degrees or maybe whatever that I'm having, how many people are there? We use now our simple proportion. From this understanding, questions can be asked, not just for you to present it. They can present it for you and ask questions from there. So it is not here, it was just a matter of how to present. But we are going to check how questions are going to be given. But for now, that's it, guys. Let's consider our revisions. But for the features and to calculate this theta, this is what is important as you consider your pie chart. So we shall see more classes as we move again, as we are together in this family till we meet again.